welcome everybody to my session. Yeah, in order to be on time, I want to make sure I'm starting on time, and I have a tendency of talking too much, so I'm trying to make sure I stay within the limit, plus trying to not talking too fast. Sometimes that's what happened to me. But slow me down too. If you have questions, feel free to interrupt. So I'm going to be talking about harnessing event-driven and multi-agentic architectures for complex Gen AI workflows. And this is the agenda, quick introduction, and also I'm assuming some of you may be new to doing generative AI types of applications, so I have a little bit of introduction, so bear with me a little bit. And then the agentic architecture, I'll get into event-driven and AI and data, and also talk a bit about RAG and agents and workflows too. And so that's the agenda. And I do have to admit that because of the length of these sessions being only like essentially 30 minutes or so I won't have time to get into demo, but I actually have a Twitch stream that I do, or live stream, so I will be sharing that with you if you want to have more conversations afterwards. So yeah, so this is a quick introduction. I'm the director of emerging technologies at a company called Callibrity. It's a small consulting firm, about 80 consultants, so just roughly 100 people in Ohio. But I myself, I'm based in Chicago. And I'm also a very active event or kind of like user group organizers too. So I'm actually running the Chicago Java users group. How many of you, I'm curious, to do program, and then in Java specifically, I'm wondering. Oh, so quite a few. That's great. Thank you. And but it doesn't matter. Then now I got into AI, and I can tell you more later if there are more times to talk about those. But otherwise, too, picture is worth 1,000 words. So just wanted to highlight some of it. I'm also Java champion. I was a developer advocate at IBM, and then also data stacks too for 6-7 years, and then now at the consulting firm. And my interest though has always been in distributed systems. So I find that there are all these things that are floating around in the industry, in the commercial, is all these things. But what it boils down to when we're developers, when we're working with complex technology, is really dealing with distributed systems, which is really one of my really biggest interests in this area. So. Okay, so I'll quickly kind of go over some Gen AI and agentic architecture thing. But let me also first ask you, how many of you are already working with AI, machine learning, that include generative? Oh, so quite a few of you too. Are you developers? Most of you are developers? Okay, great. Yeah, but anyway, assuming there are also folks who are new too, so I'm going to make this a bit, some of the introductory stuff. So just wanted to quickly kind of talk about AI, machine learning, and deep learning, how they relate to one another. When I first started talking about this topic 2 years ago when I was at DataStax, because they are Apache Cassandra kind of maker or software vendor. And so now they're part of IBM, but because of that, and I work on Apache Pulsar, so event streaming. So at that time too, when I first started talking about, I thought there was a need to kind of clarify AI, machine learning, and deep learning, how they relate to one another, but more than half of you are already working with it, so I won't get into all the details, but wanting to point out to the diagram on the right side, I wanted to, over time, I realized I wanted to emphasize the data aspect too. Without data, there won't be any AI and machine learning, as we all know. And Gen AI, too, is very much dependent also on natural language processing, too, because of its capability. I think that's what is outstanding, is the fact that it can understand spoken languages. Just think of the fact that how nice these days, right, without having had to write, when you write code, right, the traditional way is, the old ways is always you have to tell it, all the parameters, specify exactly what data types, all of these things. But these days, in other words, we need to talk like a machine. But now we actually don't need to. We can just talk like a human being to your bot too. So that's the kind of thing. So that's the purpose of this diagram. But again, AI too, I also wanted to talk about is that there are many ways of looking at AI, but we are more than just consumer here. We're a producer, we're builders, and technology developers as well, and doing all sorts of stuff around it. First of all, to the generative models, too, just wanted to kind of point out, as we all know, when it first came out, it was OpenAI, GPT 3.5, but now there's GPT 4.1, 4.0, the reasoning models too, 0.1, 0.3, 0.4, all of these, the mini ones. And as we know, too, there are other vendors, top, of the thing that there was a couple months ago that stirred up a roar was the DeepSeek being cheaper to produce all of these things. But now too, I think that the war is still on, I think on the LLM, the model side too. But at the same time too, now I won't get into all the details, but these are just highlighting some of the more popular models. But I wanted to also point out there are really the generative platforms too that are also important in the sense that I wanted to highlight, for example, there are platforms too that are from the big cloud producer platform, Amazon, SageMaker, for example, Azure with OpenAI, Google Cloud, Vertex AI, all of these, they have already kind of a lot of pre-made or pre-configured type of framework in which it already optimized for using AI on their cloud platforms. Otherwise, too, there are also other types of apps, too, that are everywhere now. And that's what we're also working on. There are private apps and all of these things, too, like meaning they're specific company domain-driven domain needs as well. But I wanted to kind of point out why this talk, and I wanted to bring up like event streaming and agentic side of things, and that's taking the center stage these days with agents. It's also because looking at it, right, the LLMs came out, it was kind of causing a stir. It was like, wow, the biggest thing, and that was a lot of hype, and still some hype too. It's basically saying that, oh, it takes over the world. It can do everything. But the truth is, as we all know, as we work more with it, it has a lot of limitations. First of all, too, it doesn't have memory on its own. It's just basically crunching all the data, and it's making predictions, right? All of the tokens and making predictions. That's what it is doing. It's not even like doing searches. It's just all about pattern matching behind the scenes. So no memory, and also the thing is, it's also probabilistic too, that model. It's not based on any deterministic type of algorithms to figure things out. It's all non-deterministic, fuzzy logic type of model algorithms. I mean, no doubt too, it is powerful. We can start to do reasoning stuff. But the fact is that we also have to know too, for example, things like if you want to add some attributions to the answers that comes back, it's all opaque. You can't do it too. Not to mention too, it's also very expensive. It's outrageous, the cost of it. So the thing is too, is that think of it like LLM is good if you know exactly what you want, and that's why the prompt engineering is very important. You need to describe exactly what you want, and it's pretty much a one-shot type of usages, right? And you can just ask it some question, you know exactly, then it will come back with the answers that you need. You need to know exactly, sort of you have a plan in mind. But ideally, that's what I'm always thinking is that, well, true artificial intelligence should be AGI, artificial general intelligence, that can actually have the agents. For example, we're talking about agents that can help in this scenario, right? The thing is, though, if you think about it, we still need to worry about coding on the transport, on more of the infrastructural layer. We need to kind of tell the agents, oh, you need to deal with what kind of protocol, what types of format, all of these things. But I think ideally, it should be the agents can actually figure that out, figure out all of the distributed computing nuances, right? Like dealing with concurrency, scalability, all these are actually what we should be achieved at. So that's why it's explaining that the AI isn't really quite there yet. But it can do a lot of things. It can surprise us. Still, it can write blog articles or design a dress and write, and essays, things like that. Don't get me wrong. But it's just that I think we are in this process. So just to kind of talk a bit more about LLM, the limitations is that, it can't address, for example, we want to, these days, right, when we're dealing with enterprise-level apps to scalability, also doing a complex workflow. And actually, yesterday, I had asked the experts panel, and I see this gentleman here, Walton, in here, and we talk about the data too. It's also very true, like sometimes, you need to have the right data to train your model in order for it to spit out the correct things for you. And the data is often missing too. A lot of the nuances, how do you deal with things that are, that are like, not like, something you can't lay out. For example, like stuff like, you need to figure, you need to book some tickets or something, and then it can just, book a flight reservation because Walton is dealing with the I'm sorry, your name, I'm sorry, like Waldron, yeah. Stu, that's why I'm sorry, but I know Waldron, right, is the last name. Anyway, so, but like basically you can book a flight, but the thing is too, it can kind of come back with all these flight combinations, but it doesn't know what your preferences would be. Maybe you want something in the morning or afternoon or night. All these little nuances is basically, that's what is kind of missing, and that's why we need agents to help us to kind of fill in all those blanks. So the complex tasks, the workflows, the memory, it just doesn't have, it cannot manage state too. On enterprise level, it's still lacking a lot of things. So now we turn into agentic architecture. And basically, too, want to talk a little bit, too, about agentic architecture. The structure and design of these systems needs to perform tasks to essentially do autonomous execution and also do tool integration, and the scalability. Also, you need to make sure is seamless as well. And also resiliency and recoverability, too. These are the kind of things that we need to really seriously think about if we're using this technology for serious types of applications. So looking kind of a little bit deeper, too, into some key concepts of agentic architecture, I like to kind of look at, if we're using a vertical architecture, so basically in an agentic world, then we need to have maybe like one agent leading in that case. Otherwise, too, you can also look at like horizontal architecture in which you can have multiple agents that are collaborating. They are of equal kind of importance, but basically too, like maybe one of them eventually will need to be the leader to decide. But the idea is that you still would need some agent to do orchestration. You can't just say, oh, go do this, and who's gonna know what to do at what time. That orchestration layer. It's much like, to me, I'm thinking, it's like an orchestra. When you are playing, if you're familiar with music, the symphony orchestra, you have all these parts of different instruments playing. You need a conductor to kind of keep everything in sync, so then the music will come out beautiful. Much like, in this case, to an IT operations, you need an agent to actually orchestrate, making sure nothing execute before other things. Let's say, right, there's a certain sequence of how you should be processing things. So you need that agentic orchestration in there. And essentially to handle all these complex task execution as well. And also, too, all of the decision making, too, when we are getting a bit more, even more sophisticated would be you want to enable agents to communicate among itself. So each agent I could be working with some LLM. They work with different LLMs. But then they could be like one doesn't have an answer. You want to train the agent so then the agent will know to go ask another agent autonomously without asking you, without asking a human to do it too. That's kind of like the ideal, to really help with reasoning and planning, and also this continuous learning type of kind of approach to it too. Okay, so now I get more into the event-driven world and AI. So, like as I mentioned earlier, too, data is in the center of AI and machine learning. And because I've also worked with event streaming, I kind of been fascinated by applying event-driven types of technique to it. So it's basically data, we know. There's also the flow of data, too. Data is not static, and data can be flowing in many directions. And especially if you're working with event-driven, event messaging, pops up type of scenarios, events can happen at any time, and it carry itself data as well. So working with data is essentially, too, I like to kind of look at this at the architecture level. That can be event-driven types of architecture. You can be implementing using message queues to handle certain type of communication, or using a pub-sub type of publish-subscribe type of having a broker in between to kind of receive messages and also essentially have elements kind of publishing, the publisher publishing the data and broker will handle it. So then whoever is interested in the messages can subscribe to it, that type of stuff. And you can kind of look at your system if you're especially designing enterprise types of apps, you can do that. And also to notice too, when we handle data too, there are also different states of data. Data can be at rest, meaning that they are in storage, maybe in a database or in a file system, that type of scenario. Or it can be in transit. It's basically, it can be, I'm like doing messaging, so data is basically traveling between different nodes as well. And also, too, it can be in use. Let's say you are doing some processing and you need to extract data from a database and you are actually putting a lock, for example, on your database, and it's in use because it's being processed at that time. And so we have to be aware of when we're working with data, all these aspects of it. And then the techniques, too, that can be applied to this, especially with event-driven way, is, for example, event streaming. As I mentioned, streaming is just, if you kind of think of, it's much like we're watching a Netflix movie, so it's a streaming type of thing. Data is traveling into your system from a source to a destination, And it can be a lot of data traveling too. So on that kind of a level, but when it applies to applications, for example, these are streaming. Again, it can be happening at any time. And when it happens, something needs to kind of handle this data. And then if you kind of look a bit too deeper into the messaging level, is basically dealing with, again, I kind of talk a bit too about publish, subscribe type of approach of doing things in which you have a broker. The broker is there to, like I'm kind of citing example in open source, the most popular I guess is Apache Kafka. And then there are different variations, right? Different companies, Confluent, for example, is a commercial company that manage their own version of Kafka as well. So Kafka will be an event streaming type of message broker that you can use, and it can be used as a platform as well. And also too, when it gets to messaging too, if you've worked with it, they're also dealing with, managing messaging sounds easy, from one point to the other. But the thing is, too, is that there are many things to worry about, like what if you're sending messages? Is the receiving side, is it receiving the messages that is intended to be receiving? Or if there are some messages not even picked up. So you have to handle a lot of things like, for example, dead letter queue, because you need to also send timing too on these messages. If they don't get picked up at a certain time, what are you going to deal with it? All those things. So just want to kind of point out this kind of can get to be quite complex. And also too, another technique is basically using event sourcing and CQRS. So CQRS is command query responsibility segregation, is a pattern to deal with the writing and the reading of event source data. So what is event source? For example, I'm just assuming maybe you haven't worked with it yet, so bear with me. So it's basically, let me give you an example. I'm dealing with order entry. Like in the traditional sense, you are keeping, let's say I have orders, so each order has one entry in the database, and it has a field called status. So the status is indicating the change of state of this particular order. But then the drawback of such an approach is that what if something happens? You want to know what happened to that order at that particular time. So using this way, there's no way you can find out. So that's why you use a new technique, is basically event sourcing, is that what you do is you're now keeping track of this change of state of this order. So then you actually have more records too of this order, but the good things about it is that every time something change of state, you are recording it, and you're also putting a timestamp on this order. So the nice thing about this is that if there are problems that happen, you can go back in time and say, okay, between this time, what is happening with that order? You can do replay, that type of stuff. So that's kind of like the goal of using event sourcing, for example. So I just want to mention too, because I work for Chicago Mercantile Exchange, and as you know, there are trading of futures and options instruments. So those places are very important. You need to be able to trace back at any time what is happening with that instrument. I'm like trying to buy this instrument, and that instrument, meaning like a futures, for example, that particular time it has certain expiration date. So each kind of instrument has its own kind of category too. So you need to kind of trace to see that particular order. What is it doing at that certain time? Why is something not happening? It's for debugging type of purpose. It's real good. So then CQRS is kind of like the accompanying type of pattern that you can use to help with command query responsibility segregation that helps you separate out the read and the write, so then you don't overwhelm your system too much. So that's kind of a quick thing to kind of talk about. Okay, so now back to generative AI, streaming usages, right? So I'm kind of looking at too, actually all of our systems too, pretty much we live in a world of event-driven. Nobody is there. Let's say I need to order food from a fast food place, and you don't just sit there. Or let's say even just going to supermarket, you are ordering something from the deli counter, and it's a long line. You take the ticket, in the meantime, you go and do something else. And so when your number gets called, you go and actually be serviced. So kind of same kind of idea. Generative AI, it's just like any kind of event-driven type of usages. So in a Gen AI type of scenario, we're talking about prompts. Prompts can be coming. Let's say you have your Gen AI system running against some model, and then you can have prompts that can come from the command line or from a browser or from your mobile app. And these can all be streaming into your app to handle. And then there are also intermediary steps of Gen AI doing a RAG operations, for example. Now, RAG is retrieval augmented generation. I'll be talking about it in a little bit. And so essentially, too, doing RAG operations, you are dealing with data that can be coming from different sources because you're augmenting what the LLM doesn't have. So in that case, I can be streaming data from a database. Let's say I'm a company, I'm a legal firm, and I have data. All the cases are not publicly available. It's only within my company. So I need to read those data from my database too. So you can get data sources from private databases or internal databases and file system or even a socket that, their data that traveling on socket. All these things can actually be supplied and augment your RAG application to interact with LLM. So message queues too can be read from for doing RAG operations as well. So then from there, then your Gen AI too, you also need to be sending requests to your LLM as well. So as we see, right, there are just lots of these messaging things that are going on too. And then, of course, not to mention, too, Gen AI, too, you're asking LLM some questions, it has to come back the responses, too. That also can be streamed back to you, and then you can process it and send it back to the requester as well. Okay, so then let me quickly kind of point out to the benefits of this event-driven approach. So as we can see, data is very dynamic, and the flow patterns, everything is very dynamic. So using event-driven approach will help too, because we're talking about able to handle the flow of data asynchronously. There's no need to be waiting too in that case, and using event streams will help it. And also it essentially to help to enable scalability and flexibility. So you can think of all of these components, and it basically can be expressed in an agentic way. You have different agents that are handling different parts of your system, and they are all carrying some data with it. These are all independent components. They are all loosely coupled. So it makes the scaling to be easier. Too, if you need to scale more, it will be easier than if you have to do everything all at once, right? Okay, so then also too, with this event-driven approach, if we are talking about agents, agents are very independent. I have many agents in my system. I can have an orchestrator. Each of them are working with different models. As we know, LLMs are kind of built for different purposes as well. Let's say, for text handling, for image, for video, all of these things. So I can have different agents handling different things, but they can all be like in a streaming type of approach. But be aware, too, there are challenges, too, with event streaming, event-driven approach. It tends to be more difficult to debug. As we know, right, the data comes in, and it can come, and usually it happens like with events. It happens if you don't have some mechanism to kind of keep track of it. Then if there's something that goes wrong, it's harder to debug too. That's kind of a known fact too. And so in other words, if we do this, we want to make sure observability should be there, needs more work to help to trace all of the data that comes in. Make sure that you can trace back. Maybe you have to have messages that has certain ID, so you can kind of trace back easier. Okay, so now let me get into the RAG too quickly. So what is RAG? So RAG, and you may have also heard of it, especially working with LLMs, and it's like seems to be de facto standard. I mean, it's just an architectural pattern. It doesn't dictate how you implement it. But essentially, too, it integrates like two components of this particular model. One is the retrieval model, the other is generative. So retrieval models, basically, again, I talk about their data that comes in that the LLM doesn't have, it. And so you need to stream in some external data from the database, from your PubSub queue, whatever it is. So, and then from there, it goes through that black box, that whole thing of LLM, it comes back with the answer. And when the answer comes back, you use the generative model to basically enhance your results too, and add to build up the context as well. So let's kind of take a look at this quick diagram too that I got from Vectorize, this company. I used to work with them too. So anyway, and so basically too, RAG is that you see too, there are a lot of streaming things that can happen in here, messaging. So number one, user submits a prompt to the RAG application. So it gets into RAG application. And at that point, too, the RAG application can be also doing semantic searches on a vector database. And that, I won't get into detail here, but as such, vector database is purpose-built to handle multidimensional data for generative AI type of purposes really well, like doing semantic searches. So you have extra data from a vector database. At this point, then the RAG will then enhance your prompt with with this set of extra data before sending it over to the LLM. So number 3, the third step, and of course, this is like a high-level look at it. So the third step is that you get into actually sending the enhanced prompt over to the LLM. The LLM looks at your prompt and then comes back with the answer. And the RAG application will then send the prompt and basically, yeah, it sends a response back to the user, but during which, that's when the generative model comes into play and enhance all of the responses that you're getting back from your LLM too. Now, I'm hiding a lot of details. Basically, as we all know with RAG, it sounds easy, but there are a lot of small little nuances. For example, when we're dealing with data in huge quantity, let's say I'm a company of, a huge enterprise, and I have to deal with all the invoices and in PDFs format, and they can be many pages. So there are limits to that LLM can handle at once, right? As we all know, there's a limit to the tokens, number of tokens it can come in the input. So within RAG too, and just to FYI, is that then there are techniques of dealing with chunking it. So chunking is how do you split up your input document, and then you have to split it in a very artful way so then you don't lose the information, for example, because now you have kind of split it up into different chunks. So all these things, and the chunking itself can be a talk in itself too. But again, I just want to point out, this particular diagram is very high level, hiding a lot of the details too. So on that level, you can also see, right, all of the data is still a lot of work to do in that part, the RAG part. And then, of course, too, coming back to from the generative model side, there are also like certain kind of details you need to handle. But at least overall, this is what it looks like to do RAG application. So now, this is just summarizing then. Again, the role of the retrieval model will be like a specialized librarian. It pulls in relevant information from a database or a corpus of documents, whatever it needs to augment your set of data to be fed to the LLM. And then when it comes back, then it will basically be the generative model will be like the writer that kind of gives you back enhanced type of responses for you too. So essentially, like here, basically this particular one, and basically saying that the generative model side will kind of look at your answers and enhance it and make it semantically meaningful and grammatically correct and checking all of these things. So that's the role of the generative model. But the RAG is basically these two models work in tandem with each other to make, to produce the answers that you're looking for in a very contextually rich kind of manner too. Okay, so now I'll get into the agent side now. So applying event approach to agents and workflows. So a bit of fundamentals to agents. So agents are essentially what it is it's authorized to act for or on behalf of another person or thing. So in this particular case, in a generative AI case, is that the agents will act on your behalf, right? It's kind of like you can just delegate essentially to it. It's supposed to do a lot of things without human in the loop. However, in reality, there's still a lot of human in the loop too. Now, in generative agents too, these are basically software entities that will orchestrate complex workflows, or if it is an independent agent, then all its task is doing, maybe it's kind of doing, and then I have another example in which there can be an IT shop, and you can have an IT coder in your team doing testing, doing DevOps, and they have different roles. But you need, again, an orchestrator to orchestrate them as well. Okay, so now, then that gets into multi-agentic systems. So usually, too, I think in our world, we're so complex, then we're dealing with multiple agents, not just one agent. So you need to also make sure all of them work together in a coherent fashion, and they each are specializing in different tasks, too. So essentially, too, you want the agents to be smart enough to know if I don't have answers, I can go look for some answers, rather than giving you, bad results or hallucinate to that type of stuff. So, okay, so then now, without kind of this thing too, I still want to mention. I know there have been a few talks too that folks talk about some protocol, and as such, now we're getting a bit too into. Okay, now we're going to be working with the LLMs, and you can write it in any way you want. But that's why too the protocol thing comes into play. Anthropic came up with MCP, Model Context Protocol, and this is an open protocol that standardizes how applications provide context to LLMs. However, There's also, okay, then this is MCP. There's also A2A, right? Agent-to-agent protocol that just came out maybe just a month or less than a month ago from Google. And essentially A2A, and it's interesting too, when I first looked at it, I was like, oh, well, that's another protocol. Like, that's just how things are, right? All these vendors. But interestingly too, I'm copying this over here. A2A love MCP, it says. And it's because over here, this particular diagram is explaining, essentially, too, MCP deals more with things on a bit of a lower level. So if you're kind of thinking you're designing your services and you have certain apps that are act as client, is LLM client, let's say, you can actually use the MCP to do it. Because on the service side, if you kind of look at, I have an agent, I'm using this protocol to do things. Essentially, I need to know a lot of things, what kind of tools it is that I need, what kind of resources, what models, all these other things. So that will be handled more on the lower level. So MCP will come into play, dealing more with the APIs, with the lower level type of kind of infrastructural kind of concerns. Not too low level, but lower level. Whereas for agents too, now we're moving on more into an application stack. We're kind of dealing with, okay, I need to find something, I need to do this and that. I'm less concerned with the lower level stuff, so that's the responsibility of agents. And so A2A protocol is supposed to be helping to help with agent-to-agent type of communication on that level. So as you can see over here, this particular example too is that you can have local agents, these are examples, and they are working with some LLMs and agent framework, and the lower level stuff is delegated to the MCP layer too. So that's how they kind of complement each other in this sense. Okay, so now I'll get back into event-driven architecture and multi-agent for Gen AI. I actually wrote an article too, but I kind of extract some of them the stuff over here. I will share with you that article too. In this slide, I'll share with that. But essentially too, we get into event-driven kind of ways, then we're dealing with event bus that will manage like event streams, and also API gateways that will handle external events, for example. And there are agents individually, there are autonomous components that has specific kind of capabilities that they also interact with different types of AI models, possibly, right? Like that too. So we're kind of talking about combining this. Now, again, it's very exploratory at this point. I don't think anybody has done it yet, so I'm kind of also experimenting in it. And then there are also event types and agent types too that we're talking about. Over here, just example of agent types can be coordinator, they can be generator or evaluator or refiner, for example. You can also, these days too, there are also agent types that are called eval agents too. Maybe some of you have worked with. And that was something I heard about 2 weeks ago. I said, what's eval agent? But they are essentially like, think of them like testing. Like the agent's goal is to test and make sure, evaluate, and making sure another agent is performing things correctly and doing things and giving you back answers correctly. So those are eval agents. So you can have different types of agents too. Their intent is to be helping each other too. Not just doing their own tasks, but eval agent is to make sure other people are doing the right things too. So that's that. Okay, so this particular example I thought would be interesting to kind of share if you're interested. I took it from the AutoGen. AutoGen is a Microsoft open source Python-based agent SDK. So they actually are more kind of better for doing agent chat kind of chat GPT or chat dialogue kind of thing, chatting thing. So they also include like humans in the loop. So I have included also the paper in archive.org that talk about this too. So you can, if you're interested, you can take a look into this. And also I wanted to quickly point out a couple of agentic design patterns too. Essentially too, there are reflection, tool use and planning, and multi-agent collaboration. These patterns, this I wanted to include because I've been following Andrew Ng. He's the leading, one of the leading AI kind of voices in this field. And he wrote some articles. He's the one that founded deeplearning.ai. And I find there's a lot of very good articles in there. So if you're interested, should look into there. But he talks about these 4 kind of more abstract level design patterns. So essentially, agents, what agents needs to be doing, this is an example of, let's say, I'm doing coding. And so basically, this is a picture of Andrew Ng and saying that, please write code for some task. And so now my coder agent will interact with the LLM and said, do this. And then it comes back with this answer do some task. But again, the right side is a critic, or more like eval agent, will then go and look at the answers and making sure it's correct, but it's very often it will find fault, and it will be saying that, well, there's a bug in line 5 or something, fix the problem. And so in this case too, then the coder agent will then send it back to the LLM and said, fix it. So this is like a reflection type of pattern, and that's what the agent, you're supposed to be also having agents that can execute this kind of things autonomously on its own and interacting with the critic agent in this case. So this is an example of reflection. And then there's also tool use too. So essentially too, what happened is that sometimes agents could be doing things with LLM, but the LLM may not have answers. So in that case, what you want to do is that you want to code it up so then telling the agent is a fallback mechanism. Essentially, if you cannot get a proper answer, please look up Wikipedia. Please look up something. So giving help to this particular agent. So this is another pattern that Andrew Ng described too. Okay, so this one I just kind of took a quick picture from Crew AI. Crew AI is another popular agent framework in Python too. So, but this one I won't get into all the details, but it's there. And then there's also a third pattern. It's basically called planning. So this is an example to kind of say that you can actually be posing a question to the LLM. By giving it this example, can be saying that I have an image of a little boy riding a scooter. What I want is actually a little girl reading a book, but in the same posture, kind of like that. So in this case too, you are have the agent kind of talk with the LLM, and then basically have the LLM figure out what it should be too. So you don't need to do all the hard work essentially. But the thing is too, is that from the paper that I read was that Andrew Ng was saying that this is still not quite very accurate, but that's something that essentially the agentic, when you're handling agents, it's supposed to also do this kind of work too, basically interacting with the LLM. So that's kind of interesting. Now, actually the pattern he talks about is multi-agentic collaboration. And in this particular case, this is also a paper too it's also on archive.org. Some university is doing this agentic design patterns with like mimicking an IT development, a project. You can have different agents that are, let's say one is doing designing things and the other is doing coding, testing, or documenting. And how do you kind of make them all collaborate correctly? So that's also a kind of work in progress. They also have some example too in GitHub. And here too, I give you the link to that paper so you can look at as well. So those are the things just what I wanted to point out before I end the talk. And basically, these are a couple of the multi-agentic libraries you can look at. Some of them, for example, when I look at it too, say with Crew AI, they already said they are doing some level of event streaming in there too. So they do it in their particular level, layer of streaming. But otherwise too, AutoGen, Crew AI, LangGraph. And also too, I learned about here is at AWS booth, they have Strands too. That's also an agent development kit too. And I look at an example. So I'm trying to also work on it maybe on my stream. So if you follow me on my Twitch stream, maybe then when I do it, you can look at it too, or look at the recording after. Okay, and then there's also, Google has also an agent SDK. And also on the Java side, some of you are Java developers, there's also Quarkus too. Quarkus also has, it's using CDI, the older dependency injection pattern, and it works with LangChain 4J too. So these are just some examples. Okay, so these are just some couple links that I have, and also an example of Crew AI that I have too in my GitHub repository. And wanting to point out too before I end is basically be aware, right? We're working with agents, it's very new. And know that using event streaming is already complex enough, and then using it with Gen AI, a lot of the security concern, all the data, you have to make sure it is secure. That's very important. And also you have to ensure that there is consistency across all of these distributed agents as well, and have to handle failures and partial results, and have to optimize all of these things. And hallucinations is still there, ethical concerns, and prompt injection too. That's another thing. I don't think it's talked enough. It's like SQL injection. Writing prompts, it could also be injected. So be careful. A lot of the security concern, AI safety is very important. So with that, I'd like to end this. I know I kind of go a little too further, but if you're interested, this is my slide deck. If you want to take a picture of this, and I will be uploading it to the site too, of this event site. So yeah, I'll have a PDF version for that, yeah. And also the archive.org paper that I share with AutoGen and a couple of things too, and also some OSS Insight collection of some of these the libraries too. And also my article on the Java Advent Calendar to talk about event streaming is here at the bottom as well. And also my stream on Twitch, and also I multi-stream to YouTube, so if you follow me. And I invite you to join my stream too if you're interested. It's very easy, actually. But okay, so with that, I want to thank you very much, and I hope you find it useful, and I invite you to have more conversations as we are all learning and exploring this very exciting topic area. So thank you very much. Yeah. Question two.
So I'm going to, I guess, speak louder so everyone can hear.
Sure.
So first of all, thank you so much. This is very comprehensive.
Thank you.
Covers basically everything
Thank you.
I encounter on my work as an AI application developer.
Sure.
I do want to follow up because I don't think there's enough conversation about testing AI. I know that there's a lot about designing, programming, debugging, observability.
That's right.
What is your kind of holistic view on testing, especially test-driven AI development, on these inherently non-deterministic systems?
Yes, that's right. So the question is about how should testing be handled, right, for non-deterministic systems like in Gen AI?
Different from evaluation. I want to separate the two concepts.
True. That's right, yes. So the question is also too about this holistically, how do we handle testing of generative AI systems when they are inherently working with LLMs, we're dealing with non-deterministic systems. That's actually a very good question, and also a thing that I'm still working on myself, kind of also sorted out, and I do agree. I think right now, especially in Silicon Valley, right, everything is about, the invention, the programming, how do you do something? But the thing is, though, when it becomes really in a real production, we have to address a lot of these areas, not just testing, actually security, for example. And I know here with Kate, too, we should talk about that, kind of dealing with that. Anyway, but back to your testing, I don't know, how, at this point, I feel maybe, when it comes into business side, right, then business will always be, we want to produce something first. You do testing, it's going to take a long time, and it will cost more. But not knowing, actually, if we make the investment now to put in the time, I think later we'll benefit from it, too. I agree. So let's say not having this concern. I think from a testing point of view, I feel definitely we need to do more understanding and also research on handling testing side, for everything you're doing. You have to make sure, especially security side. I'm really concerned too, agents, how do we deal with security side? How do you know, I can ask these questions, how do we make the agents know that they are not supposed to ask certain questions or they are not supposed to disclose certain data back, as a response, those things. So I think the thing too with AI is not just technology, that's another thing. There's also a lot of the data itself, right? And you have to understand to beyond just the mechanical part, the tech part. I mean, that's difficult enough. But you also have to make sure, yes, if coming back, right, is it giving you the right answer? Is it supposed to even give you that answer? Again, questioning AI safety, the ethics. I think that needs to be carefully thought out, especially for each different types of industry and different types of companies too. I think on all those, and in other words, if I'm responsible for a system at a bank, I have to make sure, okay, this is what it's supposed to do. I have to really be giving more thoughts into thinking through all of these aspects of it. And again, it's not just the tech side, it's really the data, the safety, all of these things. I feel it will be very, very important. But again, too, I don't know. I also feel that now with a lot of companies not quite ready, is because especially financial company, if I have data, that's absolutely important. I cannot, have any error. Everything has to be accurate. So I don't even know if generative AI is the right thing to use for what they need to be doing. Maybe they also need to evaluate, is it the right thing to kind of deal with data that's sensitive, that's going to involve security, all of these things. So I think maybe before getting into testing, have to sort out what is appropriate to use Gen AI to do. and then also then determine from that point of view. But definitely we'll need time to kind of sort out everything, I think. Yeah, so thanks for your question. That was very good. Thank you. Yeah. Yes, yes.
Yeah, so I'm Arnab. I work with Hyperswitch. We are trying to make payments open source.
Yeah.
And, so my question is along the similar lines. So what we are trying to do is so we get emails
Yeah.
with questions,
Yeah.
and we would want to reply to those emails via generative AI. Now we have something in place, but
Yeah.
it's giving sort of 60% accuracy. I would want your opinion. That do you think it would be a good idea to use like detailed generative AI in that?
Oh, yeah. Sure. The question is about whether it's wise, right, to use generative AI type of capability to generate emails, but for payment type of application. So I think it all depends. I think, again, in other words, well, in this case, now you make me think. Maybe if you want to use for generating email, then you need to have another sort of like a quality assurance or safety officer agent to kind of make sure, okay, what gets generated in an email is safe, right? For example, things like that. I think maybe you need to do that extra step of putting in this guardrail in place. And that's what I can think of right away. Yeah, maybe, yeah. Not just like generating something autonomously. No, you actually have to have human in the loop and put in place some kind of measure to check it too. I think that's what I would do. Yeah, yeah. Okay, thank you for asking. Yeah, okay. Anybody else have questions? Yeah, sure.
This is a very general. Where do you find those papers?
Oh, the papers of like the different AI, generative AI. I actually really follow Andrew Ng. I really like his stuff too. So on deeplearning.ai, like he has some blog articles. And there's also papers too on archive, archive, all the research paper, .org. That one, there are also lots of papers too.
No, I guess it's not literally where you find them, but like how do you determine the paper is high quality for you to read?
Oh, to determine it's high quality for me to read, like a paper. It is very true. I do have to say, though, it's interesting. These days, when I first learned about this field, that was two years ago when I was at DataSex, I remember started reading, I absorbed everything in because I was new. And at the time, I only had more traditional machine learning kind of knowledge, too, because from IBM days. So I was like learning Gen AI, I was like learning everything absorbed. But it is very true. Over time, I'm starting to being able to become more selective and also knowing what is right and what is wrong. I don't know how to say, but sometimes if you read enough and then you are seeing what is happening and what can and cannot do, then I start to be able, you kind of gain that knowledge or kind of confidence to know what is right or what is wrong. Now, for example, these days, one thing I really do not like is a lot of all of a sudden in the trade magazines or paper, they would come out and said, oh, agents coming now, and it almost seems like if I have to visualize this, it's all these monsters kind of coming into town, agents gonna take over the world, the software engineers gonna lost their job. I really think it's ridiculous. I don't know why they do it, and basically, as I mentioned, I think agents, if we want to have it to be truly able to take our jobs, it would take years. It's not gonna be overnight. I mean, true. If you, for example, I was at a talk by 1871 in Chicago, and it's an entrepreneurial hub, and that was very good. But anyway, they invited Replete, this company, to come and do talks, and they are code generation, right? They are saying, okay, we use agents, so they were demoing, oh, I want to do this, and then it generates the code. True, it looks good, right? It generates some code, but very specific tasks too. And then, funny too, in the panel, somebody was saying, you know, I used to have 4 engineers working for me. Now I only need 1 because I don't need them because I can use Replete to generate all the code. And I'm thinking, no, all you're doing just generate code. And so I was going to ask question, but good. Another panelist was saying stuff like, he said in a very nice way. He said, you know, we live in a complicated world. A lot of the things like, you know, scalability, complex flow, I don't think Replete can handle it yet. so even that's what I'm thinking. And again, I've been working with distributed systems. I'm thinking distributed systems are one of the hardest things to solve in computer science. And No agents. I don't think any agents can figure it out. How do you deal with concurrency, threats, and all of these things? I don't think so. That I haven't seen. So I wanted to kind of argue that, well, until an agent can figuring out these distributed systems complexity, I'd say, okay, I'll be starting to be convinced it can take over the world. It's just a matter of time, maybe, but not now, I think. It will take time. Right now, what it can do, yeah, doing like some very clear instructions, a prompt of generating some code to do, I don't know, moving messages, writing emails, yeah, fine. I mean, I don't dispute, but it's just if it gets to all the complex thing, I don't think it can do it yet. So that's what is required to actually to do real serious stuff, flight reservation, end-to-end systems. Yeah, and still talk about the travel stuff too. That's very interesting. You need to do travel. So many variants in there, so many things to be concerned with. It needs human beings. It needs better systems. You need something to tie together the whole thing. Yeah. So that's what I think. So, thank you. Thank you very much. Yeah.